Hello and welcome to week 12 of Code Wrangling for Beginners. We can't do much in this week because obviously we've covered most of the material on the course, but I did want to kind of go back to the beginning and refresh a couple of ideas. Firstly, I wanted to talk about processing and why we've been learning processing. Processing is a language that's derived from Java, and Java is the language you'll be learning in the first year. Java's actually a very popular language. Java is used to build Android devices, it's used to build many commercial web applications, and it was even the programming language of Minecraft. Java is a very popular language. It's definitely up there in the sort of top 1, 2 or 3, depending on how you want to go out measuring them. Here we see a list of job advertisements, and we see that Java's very high up there. Also notice that the next one down is Android Java. It is basically Java syntax, but it requires a knowledge of Java. Also notice that C# is down there. C# is a language that Microsoft derived from Java that looks a lot like Java, and the translation from Java to C# is again very simple and straightforward. There are a number of similarities also between Java, C, Objective-C and C++. Java's a very big language. It's not quite the world's most sexiest language, but it's still a very highly in-demand language. As you can see here, this is the percentage of matching postings with the word Java in it. Often when people look for developers, they're looking for multiple languages. So you'll see someone who's good at Java is also good at JavaScript, for example. But you can see here that in terms of demand, Java's very up there, followed by JavaScript. Python and Ruby, the kind of more modern languages, are much further down that stack. They're growing, and eventually they might catch up, but at the moment they're still the big languages. Again, different languages are used in different contexts. If someone's starting up a new kind of internet startup now, they might use Ruby. If they are doing stuff with artificial intelligence, they'll probably be using Python. If you're doing something on the web, you're going to be using JavaScript. But again, Java is a good kind of entry point for all those kind of languages. And it's still more popular than all of them. Java, as I've said already, is the programming language of choice on Android. I would have loved to have actually started off by getting you to build an Android app, but I felt that really the complexities of using a fully fledged IDE development environment inside class would have actually overwhelmed you a bit. So we kind of erred on the side of simplicity and went with Java, plain Java. Something you don't see a lot of, and you're probably not aware of, is that actually Java's used in a lot of web apps. So basically, if you've been to the bank, for example, your bank's web server doesn't run PHP, it's been running a Java system of what they call web applets. This allows people to build very large, very scalable, very reliable, complex applications using Java. So again, not very visible, but it's very popular. I also wanted to put the Java syntax within some context in terms of the language. So originally, the syntax for Java began with this language called C, invented by Kernighan and Ritchie back in the late 1970s. C was used to program this first operating system called Unix, which you might have heard of now as Linux. Unix is the underlying operating system of many large machines, but also Linux and the Mac operating system, the low-level Mac operating system. C gave rise to this language called C++. C++ basically was the C programming language with extensions to include object orientation. They were felt by many to be very clunky. Also, C++ has problems with memory management, which is again something I don't want to go into deeply. And so a group at then Sun Workstations invented a language which was supposed to have all the power of C with objects, but to be more simple and elegant, and to have a garbage collector. They created Java, and that's a nice, good intermediate language. It's not quite as dangerous and sharp as C. It's not quite as fast, but it's quite fast enough. And it basically is quite a pleasant language to begin with as a starting language. Java itself has given rise to many other languages, the most significant one of which is C#. This one has a syntax which is very close to that of Java. It was originally Microsoft's version of Java. Again, the syntax of C# has drifted slightly away from Java, but again, if you're good with Java, then moving into C# actually should be not quite a shock. And then there's also other languages. There's a language called JavaScript. JavaScript wasn't derived from Java per se, but it takes a lot of elements. A lot of the syntax is very similar. It has a kind of different underlying model, particularly in terms of objects. But Java was meant to be an object-first language with object orientation built in from day one. Right. What I want to talk about mostly for the rest of this talk is Java versus a spreadsheet. The idea here is that we'll talk about some things, and I want you to try these things out. So here we see how we define a variable in Java. We go int counter equals 2. In a spreadsheet, what you would do is you'd have one label in a cell called counter. You'd type in 2 into another cell. Then you'd go up to insert, and you'd say define name, and you define the name of a single cell or a range of cells, and then you could use that name in further calculations. And equally, you've got float, distance, string. The only difference between Java and an Excel spreadsheet at this point is when do you define what the thing in the cell is. In a spreadsheet, you normally only define what's in the cell by the nature of the formatting. In Java, partly for kind of historical, partly for optimization reasons, you have to tell it what the thing in the cell is. So, for example, is it a counting number, is it a calculation number, or is it just a piece of text? Just like Excel, the counter and we can perform expressions inside formulas. So we use star in Java and in Excel to use multiply. We use slash to do divide. Subtraction and addition are there. And again, once we've defined various cells, we can actually use them in the formula. In Java, we have arrays. Array is just a list of items in order. So again, using the same sort of syntax, we give a list of items a name. We use the square brackets to represent it's a list. And then we can use equals, squiggly brackets, braces, and then we can give it a list of items separated by commas followed by a closing set of braces. And at the beginning, we tell it what's in it. Inside Excel, we just type in the list, we give it a name at the top, and then we can again define it as normal. Both Java and Excel have string functions. So, for example, in Java, we can go hello plus the 0th item of names, and in Excel, we can go concatenate hello that. Now we come on to the kind of major differences. Inside Excel, if you wanted to concatenate hello with that name, you'd have to cut and paste this equation, the expression, a number of times into the next cell you wanted to do. Now, that's okay and it works fine, but the problem is if you then make the array bigger, you have to then copy all the expressions down, but also then it's possible to then alter one of the elements to make it slightly different. That can be problematic, particularly if you change the expression. You might go down and not fill all the way down. You might fill down from John all the way down to Robin, but Julia gets left behind. In Java, we have this for each expression, which you've seen already, and it just basically applies the it applies that one line and then reproduces it against every item in the list. Let's carry on. If statements. This is where it gets much more difficult in Excel. In Excel, an if statement is an expression. Okay, it's just a way of choosing one number over another number. In Java, you can actually type a huge amount of extra code, extra steps inside those brackets. So it's actually quite far more powerful. But again, both if statements can be used on single items. Obviously, we can loop an if statement fairly easily. Both Java and Excel can both perform substring operations. So, for example, here we've got write inside Excel, and we can say from John get the second characters, second to end characters. So we skip out characters 1 and 0, and we get the H and the N in John. So that gives us that cell value there. In Java, as you've seen already, we use the kind of concept of substring. While loops. Okay. One of the things you might want to do is increment a value all along. And what we do inside an expression is we say it's equal to that expression, the previous expression, plus 1. And we do a very similar thing inside Java. The same for for loops. And then we can also use built-in functions. So for example, we can go equals sine of that angle. And again, we can do that in a loop. But in Excel, we can't define new functions. Okay. Now, we can in a complicated way because you can define functions inside a programming language, but then that's not part of Excel. Okay, and obviously inside Java, we can easily create a user-defined function. We can't draw really easily inside Excel. We can create charts, but we don't have arbitrary drawing powers. And we can't build large, complicated programs using abstractions as we can inside a language like Java. Okay, that's a quick reminder. So just to remind you about the assessment class on Thursday and Friday, bring your work and your data. You're going to be asked to speak for a few minutes, and you might want to say, what is the data, what's the source, what were you trying to do, and what did you learn? Don't forget to zip your projects up and then submit them finally to not turn it in as it says here, but upload it into the system. And I hopefully will see you all, and hopefully